much. So if I connect from here, this reaction is called free radical substitution. This is called free radical substitution. What is free radical substitution? It's a process in which free radicals are produced and they are able to continue the reaction replacing chlorine in the methane molecule or any alkane. Are you able to hear me?
Yeah, I can hear you, I think.
So mechanism, I'm starting the first mechanism of organic chemistry. Mechanisms are considered to be the very important feature, actually the difficult feature of organic, but organic has one very good point. If you remember it, you can do it much better because numericals are rare. In the physical side chemistry, numericals are the major issue. Numericals give the maximum challenge. Now look carefully, the mechanism of this process, this is Cl2. Cl2 means Cl and Cl, this bond is logically, what type of bond is this? This bond is logically non-polar. Why it's non-polar? Because the two elements are the same. If two elements are same, remember when a bond is between same elements, the difference of electronegativity is always zero. Such a bond is always non-polar. Can you repeat? Chlorine molecule means ClCl. When same atoms, same elements join, the electronegativity difference is zero, and such a bond is always non-polar. So can you please repeat what is the case of a similar bond, similar element bond?
It's non-polar because it's two negative, electronegative, basically.
No.
Yeah.
Read this.
Yeah, it's non-polar, so like the electronegativity is zero. Yeah.
No. The electronegativity is not zero. The delta signs means what?
The change in electronegativity?
Yes, the difference.
Okay.
The difference in electronegativity is zero because they are same. So suppose electronegativity of chlorine is 3. That will also be 3. 3 minus 3 will be equal to 0.
Yeah.
So why Cl2 is non-polar? Because they are same atoms. What is the concept to remember? Whenever you connect same atoms, same elements, always the molecule will be non-polar. For example, I make a bond of oxygen. Double bond. That molecule is also what? Non-polar. Why it is non-polar?
Because it's still the same two.
The same, right? Similarly, if I connect nitrogen with nitrogen, it's again what?
Non-polar.
Bond between same elements is always non-polar because the difference in electronegativity is zero. So we start our concept because we need bonding to be back. This is a chlorine molecule, ClCl, and this molecule is non-polar, and due to non-polar, it is very less reactive. It's not willing to react with anyone. It's a stable molecule. Now, what we are providing energy in form of ultraviolet rays. You know ultraviolet rays, if you are outside the room in the open sun, ultraviolet rays are there. These are the same ultraviolet which can really create a problem for people who stay a long time in the sun. These are the rays which are present in sunlight. They contain a lot of energy. These ultraviolet rays break the bond. What happened after bond breaking? Chlorine, two atoms separate from each other, and these chlorine atoms are called what?
Free radicals.
Free radicals. So can you repeat what is the step one? The
You
mechanism.
have a non-polar bond under UV which undergoes homolytic fission and produces two free radicals.
Very good. And these free radicals are
Very reactive.
very reactive. So first step is there. Now, methane is present there. Let's talk about methane. This is CH4. The free radical, one of the free radical attacks on methane and kick out hydrogen, one hydrogen from there, and remove hydrogen from the molecule and sit in place of it. It's just like in a class, one guy, a bit powerful, bit healthy, can displace a bit weaker student, and he says, I will sit here. So chlorine gets into methane and kicks out a hydrogen. The hydrogen which comes out, this is hydrogen, and it combines with HCl. There are two chlorine actually. One chlorine goes into the molecule and one chlorine get to the exiting hydrogen and form HCl. So what happened here? I show you the process in bonding style. This is methane. This is methane structure, and we have two chlorine radicals, okay? One radical removes the hydrogen and sit in place of it. What will happen? The hydrogen is removed and one chlorine take up its place. Now that hydrogen is out, the second chlorine will engage the coming out hydrogen and it will make HCl. This is called, I'm sorry, I've written step 4. This is called step number 2.
Okay.
It's called step number 2. Now, during this step, a free radical is attacking methane and ejecting one hydrogen. This is actually able to produce a free radical of methane because methane has lost the hydrogen. This second step is the attack of the the second step is the attack of the chlorine free radical. Now I show you the step 2 again for more discussion. This is methane. A chlorine free radical attacks and kick out a hydrogen. Now it is CH3 and I get HCl. The CH3 free radical is there and it will attack a chlorine molecule and removes the process. Look at the process carefully. This is a chlorine molecule. CH3 take up a chlorine from here, creating a chlorine free radical. First free radical attack methane. Methane is now methyl. It attacks a chlorine molecule and then a chlorine free radical is produced. The chlorine free radical will again attack on whatever comes in front of it like methane or even CH3Cl. This second step is actually the attack of the free radical. Now this reaction continues every time a free radical attacks and it also produces a free radical. It is just like a very interesting example. It is like a horror movie. The horror movie zombies, etc. They attack a person and they make him also a zombie. So these chlorine free radical attack methane and they make a free radical from that also. Free radical will further amine. So this reaction continues as a chain reaction because free radicals are being produced. These reactions are called chain reaction. And then look at the step number 3. How this process will stop? When a free radical come in front of another free radical, then a neutral molecule is produced. So when two free radicals bump in each other, the reaction stops. This step number 2 is called propagation. step number 3, where the reaction eventually stops, is called termination. So there are 3 steps. The first step, when chlorine-free radicals are produced, it is called initiation. The step 2, when chlorine-free radicals attack methane, further free radicals are produced. It keeps on going on like a firework, and this is called propagation. And when 2 free radicals bump in each other, it is called termination reaction.
Okay.
So now give a side heading, mechanism. You have to copy this.
Yeah, done.
Now copy this screen.
Copied.
Give a side heading, initiation. No need to copy these animated lines. Just copy this one.
Okay, copied.
And now copy this.
Okay, I've copied this one. Yep, that's fine.
Why CCl bond break? Because in the mixture, CCl bond is more susceptible to the UV attack. The second step is called propagation. Copy this. We have discussed it already.
This is just a chlorine molecule
Chlorine
and
free.
no, the second one. The second one.
The second one is actually methyl free radical is
Yeah.
attacking chlorine.
Right. Okay.
It is just like that zombie example.
Yeah. Okay.
Free radical is reactive, and the free radical wants to attack whatever comes in front of it. It's so reactive that it is ready to attack anyone. Doesn't matter who comes in front of it.
Okay.
So if chlorine is used in excess, the process continues, and one by one, all hydrogens are being replaced. So right under it, if chlorine is available in excess, If chlorine is available in excess, the process of propagation continues. If chlorine is available in excess, the process of propagation continues. You have to copy this bracket only. Have you copied the two equations?
Yeah, copied.
Now, similarly, the process continues, and you can remember it in this way, that it is chlorine radical attacking the chloro product of methane, and one by one, all hydrogens are replaced. But whatever is going on, it is actually the game of chlorine free radicals. They will continue this game. So a mixture of products will be obtained. Different products are obtained in a mixture. Now, how this process stops? When two free radicals bump in each other. So right now, number 3, termination. Look at 3 examples of termination. What is termination? When two free radicals hit each other, they form a neutral molecule. The free radical is not there, so reaction stops. This is called termination. You have to copy this.
Yeah, okay, done.
So write under it, when two free radicals when two free radicals combine, a neutral molecule is produced. A neutral molecule is produced. This is called termination. This is called termination. So now there are 3 steps: initiation, propagation, and termination. I will share this sheet so you can memorize it. What is the mechanism? Mechanism is free radical substitution, the name of the mechanism. In organic chemistry, there are names for every mechanism. The mechanism is initiation, propagation, termination. Now, write under it, this is called free radical substitution mechanism. This is called free radical. This is called free radical substitution mechanism. Now, give a new heading, extended substitution. Sometimes the process stops, but again it can roll over because the alkane products like C2H6 in the final step may undergo substitution also. This is another chain reaction. This is a very complicated step because chlorine free radicals would be jumping here and there. And if they come across the final product like C2H6, suppose, for example, that is how C2H6 was produced. Look at the screen. C2H6 was produced here. When two CH3 molecules combine, C2H6 is produced. That C2H6 is technically, this C2H6 is technically ethane. So sometimes the ethane molecule also gets struck by chlorine free radical, and this starts another chain reaction which makes it very complicated, but it is not required in detail. You have to now copy this screen.